Hello class, I'm going to show you how to use Pascal's triangle to expand a binomial. So first of all, Pascal's triangle, it's a triangle made out of numbers and they follow a specific form, a specific pattern right here. For example, to get this 2 on row number 3, you add 1 plus 1. To get the 3 on the next row, you add 1 plus 2 and 2 plus 1 and so on and so on. So 1 plus 3 makes 4, 3 plus 3 makes 6, 3 plus 1 makes 4, and so on and so on. You see that? 1 plus 4 makes 5, 4 plus 6 makes 10, 6 plus 4 makes 10, and so on and so on. So we could easily draw the next row number 8. Notice that all the rows start with a 1 and end with a 1. So the next number right here on row number 8 would be a 7. The next one would be a 21, 35, 35, 21, and 7. Please notice that the first and the last number are the same. So are the next numbers, and the next numbers, and the next numbers, like that. That's just a little way to recognize Pascal's triangle or to make one from scratch. But how do we use Pascal's triangle to expand a binomial that looks like this? X plus 9 to the 4th power. Because we are raising this to the 4th power, we're going to use the row that has a 4 on the second number. So we're going to use the numbers 1, 4, 6, 4, and 1. And the way Pascal's triangle and the binomial theorem work is we're going to take the first number, whatever it is, in this case is x, we're going to raise that x to the 4th power. Then we're going to decrease the exponents, then 3, then 2, then 1, and then 0. Okay, now we do the same exact thing, but increase in order of the exponents of the second number. So in this case, it's going to be 9 to the 0, 9 to the 1, 9 to the 2, 9 to the 3, and 9 to the 4. When we are adding, when we multiply a binomial that has addition, in the first, that has addition between the two numbers, we're going to make them all plus signs like this. And all we have to do is simplify this exponent. So remember, to simplify these exponents, we have to use PEMDAS, the order of operations. Remember that any number raised to the 0 power is 1. 1 times this 1 here makes a 1. You don't have to write it. And then x to the 4th power. Then we multiply 9 to the 1st power, which is 9. And 9 times 4 makes 36x cubed. Then 81 times 6. 9 squared makes 81. So we just have to multiply that. Let me get my calculator out. And this is 81 times 6, and the answer should be 486. 486 x squared. 9 to the 3rd power, 9 times 9 times 9 is 729. We multiply that times 4, and it gives us 2916x. Notice how x to the 0 power and 1 make a 1. So all we have to do is on the last number is take 9 raised to the 4th power, and you get that this answer is 6561. And so this is the expanded form of that binomial when you multiply it by itself 4 times. Okay, if you were to multiply it by itself, x plus 9 times x plus 9 times x plus 9 times x plus 9, it would be a lot of work, but you would get the same exact answer. Now, the long way and the Pascal's triangle way should give you the same answer. So if you want to check it, good luck with that. The next one, we are going to do something similar. The only difference is we have a minus sign instead of a plus sign. So I'm going to show you what to do with that minus sign. But remember, we're going to use to expand this, we're going to use the row that has a 3 on the second number. So the row that has a 3, the row that has a 3 on the second number is going to be this row here. So we're going to use a 1, 3, a 3, and a 1 to expand this. 1, 3, 3, and 1. Please do yourselves a favor and give yourself a lot of space. We do this exactly the same way. At the end, we just do something different because of that negative, but we're going to take whatever the first number is and we're going to raise it to the third power. Whatever the first number is to the second, to the first, and to the 0. Then we take 11 and we do exactly the opposite. We're going to increase the order all the way from 0. So times 11 to the 0, 11 to the second, 11 to the first, 11 to the second, and times 11 to the third. Here's the difference when it comes to negative. We always start with the positive right here. You don't have to put that positive there, but we always start with the positive and then we just switch signs. Positive, negative, positive, and negative. And all we have to do now is simplify those expressions and we'll be finished. Remember that 11 to the 0 power times 1. 11 to the 0 power is 1. 1 times 1 is 1. So we have a 1. But then 2 to the third power is 8. 2 to the third power is 8. And x to the third power is x to the third power. So that's what the first term simplifies into. We might need an extra line on this one because we have a 3. We have a 2 to the fourth power, which is 2 to the second power, which is 4. Sorry about that. And then 11. And then x to the second. We have 3 times 2 times 11 squared. So it's 3 times 2 times 1, 21 times x. And then notice that all of this becomes 1 and the next number is just 11 to the third power. 11 times 11 times 11 makes 1331. So the answer would be here 8x to the third minus 132 x squared. Let me double check that. 3 times 4 times 11. 132x squared plus 6 times 121. It's 726x minus 1331, and this would be the expanded form of 2x minus 11. You might want to put pause on this one and then try the next example by itself, example number 3, and then see if you can get the answer that I will get as I do it. Because we are raising this binomial to the fifth power, we're going to start with Pascal's row that has a 5 on the second number. So it's going to be 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. The next thing we do is exactly what we did on the previous ones. We're going to start by taking 3x to the fifth. That's because we're raising this to the power of 5. Then 3x to the 4. 3x to the 3. Okay, then I'm going to take 5. Don't worry about the negative. Just take about the 5, and we're going to raise 5 to the 0, 5 to the 1, 5 to the 2, 5 to the 3, 5 to the 4, and 5 to the 5th. You see, you would never give enough, you would never give yourself too much space here. Make sure you have enough space on your paper when you're doing this. If you remember what we do when there's a negative, we start with a positive. Then we just alternate signs. So if it was a positive, it will be all positives all the way across. But right now, because we have a negative, we alternate the signs: positive, negative, positive, negative, positive, and negative. Okay. Now we're gonna simplify this. I'm gonna do it really quick. You guys could double check your numbers because I don't want to make this video too long. But this would be 3 to the 5th power times x to the 5th. 3 to the 5th power makes 243. X to the 5th. This would be 81 because 3 to the 4th power is 81 times 25. 20, 25, x to the fourth. This here would be 10 times 27 times 25. It'll be 6, 7, 5, 0, x to the third, minus, that'll be 10 times 9 times 125. So 90 times 125 will be a huge number, x squared. The next number would be 5 times 3 times 625. And that would be 9375x. And the last number would be just 5 to the fifth power, which is 3125. And this is how you use Pascal's triangle to expand a binomial. Keep practicing, check your answers, double check your work, and have fun with this.